everyone, today we're going to talk about image and bijection proof. I know I promised that I'll try not to make videos at midnight and it's almost midnight again. Just to avoid me making mistake or typos again, I asked my best friend Daria proofread my solution to make sure that there's no mistake or anything. Thank you, Daria. Already here. Thank you, Daria. I love you. Okay, anyway, let's start. First of all, let's talk about the definition of image. So if we have a function that mapped from A to B, and C is a subset of A, then the image of C under F would be f of C, which is if you take element from C, then all of f of C, the whole collection would be your image of C under F. I'm writing this down here because I feel like Mike could test you on definition, or definition of image, definition of injectivity, surjectivity, bijectivity, such things. So make sure you know the definition. Anyway, the first example. So we have a function that's from R to R, even by fx equals to 9x squared over 1 plus 3x squared. And I want you to show that the image of the function f is an interval from 0 to 3. I know a lot of you don't know how to find the image of a function. Well, I think you should know from your calculus course. I think that's like at the very beginning of the semester. So in 102, we don't need to see how you find your image. We just need you to find it and then prove it. So your process of finding your image, we don't care how you find it. So I suggest you to use calculus because it's like the most accurate way. But sometimes you can use inequality as well, as I'll show you here. So the first example, I actually have two examples for image question, and I proved those two using different way because I want to show you like there are different ways to prove the same question. I don't need you to know all different types of proof. As long as you know one and make sure you know exactly what you need to do, you're fine. Okay, so to show the image of f is the interval from 0 to 3, this is a set equality question. As we mentioned many times, if we want to prove two sets are equal, we need to show they are subsets of each other, which is this. Okay, so first of all, we show this side. Again, as I mentioned many times, you should start with an arbitrary element from your f of r, which is the image of your function. So we pick an arbitrary element y in f of r. Then we know that there exists x in r. Here your r is your domain. Okay, so we know that there exists x in the domain such that y equals to fx equals to 9x squared over 1 plus 3x squared. Now what you need to show is that y is also in this interval, which means you need to show y is greater than or equal to 0 and smaller than 3. This is what you need to show. Remember, this is what you need to show, okay? So what I did here, I didn't use AGM or anything. I just did a direct proof using inequality. So we know that 9x squared, this whole thing is greater than or equal to 0. Okay, I wrote it here. The other thing we know is that the denominator is greater than or equal to 0 as well. Okay, actually not equal to 0, greater than 0. So based on this, we know that, based on this and this, based on those two parts, we know this. okay, because the denominator and the numerator are both greater than 0. Okay, that's why the whole thing will be greater than 0. How do we show it's smaller than 3? Well, we know that, I'm gonna erase this part. We know that this is true, okay? Because this is true, when you divide, we know 3x squared is smaller than 3x squared plus 1. If you divide by a smaller number, will give you a bigger number, okay? This is true because divide by smaller number will give you a bigger number. Okay, so we know that this whole thing will be smaller than this, which is 3, and we're done. Now we know this is true. Okay, so we know y is in the interval, which means the image is a subset of 0 to 3. This is the, I think this is an easy direction. The other direction is a bit confusing, but I hope everyone can understand this, okay? So the other direction is you need to show the interval 0, 3 is a subset of the image. As always, we pick an arbitrary element from 0, 3, right here. So we pick an element from here. And what we need to show is that there exists x in the codomain such that this is true. Okay? We need to show the existence of x. Existence of x. So to show this, there are two different ways to show this. I used the inequality way here. But the other way, probably everyone learned it from lecture using quadratic formula. The other way, I used the other way to prove the second question. So we'll see that as well. But I want to show you this way as well, okay? So we need to show the existence of x. And we have this equation here. So I want to rearrange it to isolate x. Okay, so this is what I did here. This is just like rearrangement to isolate x because I want to show x exists, okay? So we do a little bit manipulation and eventually we'll get this step. 3x squared equals to y over 3 minus y. Notice that we can divide, so from this step to this step, we divided by 3 minus y. We can do that because we know y cannot be 3, okay? We know y is from 0 to 3, so it can never be 3, so the denominator is not 0, that's why you can divide it. Make sure you mention that. Anyway, so based on this, we know that our x exists if and only if this whole thing is greater than or equal to 0. So if this is smaller than 0, this whole thing is smaller than 0, then our x does not exist. So we want to show this is true. Okay? So based on our assumption, not assumption, because we picked an element from the interval, so we know this is true, but this you can multiply -1 on all sides, and you'll get this, okay? This is times -1. Okay, and then you add 3 on each side, you'll get this. And then you can divide by 3 minus y. And eventually you should get this. Oops, did I do something? No, I didn't. Okay, so we have this. So we have this is greater than 0. Because we know y is greater or equal to 0 and 3 minus y is greater than 0. Okay, so based on this and this, we have this. Therefore, x exists. So once you prove that x exists, you're done. So based on this, we have 0 to 3, this interval is a subset of the image of the function, therefore they're equal. Okay, so this is one way of proving this question. The other way, I have another example to show you. So this function is from R to R as well, fx equals to x over 1 plus x squared, and I want you to prove that f of r equals to the interval from negative 1 over 2 to 1 over 2. Again, we first prove the image is a subset of the interval. So pick an arbitrary element from the image. There exists x in R such that blah blah blah. Notice that what I wrote here. So I'm gonna erase those to show you what I want to show. Just bear with me for a moment. Okay, those are not important. I'm gonna erase those. What is important, what I want to emphasize is that, let's say you don't understand this part. After all my explanation, you don't understand this part. Okay, now I want you to write down this sentence. If you don't understand this question, you don't know how to do this, please write down this sentence. Okay, for the first half, write down you want to prove this, and write down the first sentence. So you don't need to change anything. Just change this if your domain is not real number, so change it to your domain. The whole thing inside, okay? Inside, change the domain, change your function here, change your equation here, change your function here, and everything else you can keep it the same. I think most of you should be able to prove the first direction, but even if you don't know how to prove it, write down this sentence, okay? And try your best to get this. Try your best. If not, write it down, okay? Even if you don't know, please write it down. You might get partial marks. This is my way of giving you tips of get partial marks even if you have no idea what to do. Okay, the second half, same thing. Write this sentence down. Alright, write the sentence down. What you need to change is this. Change this to your image. And change this. Okay? Those are the same for almost each question. And if you write it down, you might get partial marks. So please write it down and try hard to get to the very last step. X exists. Okay? So same here. We write down the first sentence, let y be an arbitrary element of the image, and there exists x in the domain such that y equals to f of x. And we want to show, again, we want to show this is true. So what I did here is started with what I wanted to do, and eventually I reached a statement that is always true. So I started with what I need to prove. You should not do that, but sometimes it's easier to start with what you need to prove. So make sure you check each of your steps. Make sure they are reversible. If they are reversible, then go ahead, put if and only if here. But please have this, okay? This is really important. If I don't have this, if I remove this, this is only rough work. Okay, if I don't have if and only if, this is just rough work. So please have if and only if at the front. Okay, those manipulations are pretty simple. I'm pretty sure you know how to do those. So let's skip that. So this is like just a normal inequality that you've been tested on, so let's just skip that for now. The second half is you need to show the interval is a subset of our image. Again, write the sentence down first and try your best. What I mean by try your best, here is a typical way of doing this. I'm pretty sure everyone learned this in lecture. So you try to manipulate it such that the whole equation becomes a quadratic equation. Okay, so this is a quadratic equation, which means you can use your quadratic formula. What do I mean by that? We know that because we want to show x is in real. We want to show there exists such x in real number, which means you want to show this equation has real roots. So in order to show that, you can just use your quadratic formula and show your discriminant is greater than or equal to 0, which is what I have here. Okay, so you want to show your discriminant is greater than or equal to 0. If you have that, then you're done. Anyway, so I did that and it's equal to 0, so it exists. So we have this as a subset of, this is a subset of the image, so they are equal. Okay, I think that's it for image question. I hope you understand at least like 80% of this. If not, I forgot to mention this. If not, I posted some extra practice questions. It's in the Google Drive right here. It's called Image and Bijection Extra Practices. So I posted quite a lot of questions that you can practice. If you've done all the all the textbook question, go ahead, try them out. I might send a partial solution for bijection question. Okay, so the proof is like way too long. I don't want to write it, but I can provide you like a partial solution to show you, like to tell you if it's injective, surjective, bijective, or neither. That I can do. Okay, I might do that on Thursday before your quiz, you know, like Thursday morning or something, because I want you to try them first. If you want a solution before that, feel free to email me. Okay, anyway, let's go to the next topic: injection, surjection, bijection. So those are the definition. This is a definition, I took it from the textbook, and those are some variations of definition. I personally think it's helpful to read this, okay, because sometimes using those definitions will be easier than the original definition. So have a look, okay? When you are free, have a look. For people who are still confusing, who are still confused about this topic, I draw some diagram here to show you what are those. So the first one is not injective because it's 2 to 1. See, 2 to 1, it's not 1 to 1. There are two elements in your domain that map to the same element in your codomain. That's why it's not injective. It's not surjective because here, this element in your codomain is lonely, has no friend. That's why it's surjective, okay? The second diagram here, it's injective, not surjective again, because you have an element here that he has no friend, he's lonely, you don't want him to be lonely. That's why it's not surjective. This one is surjective, not injective, because this guy has two friends, okay? That's why it's not injective. Well, everyone has friend here. Everyone in your codomain has friends, but this guy has two friends. That's not good. You should only have one friend. Oh, that's not a good thing. Okay, let's say those are wife, and this is like husband. Okay, let's say that your wife is your domain, husbands are codomain. if one guy here, okay, this is not good. Okay, let's see, this is like girls, this is boys, okay, and they want to date. The function is date. Okay, so now it's not injective because this guy here, he has 2 girlfriends. It's not good, so it's not injective. Okay, so injective is like one boy has more than 1 girlfriend. It's kind of like that. Okay, it's no, I don't think it's a good example, but it's kind of like that. I think you can get it. For injective, not surjective, is when we have a single boy. Okay, single boy has no girlfriend. Well, bijective is when everyone's happy. Everyone's happy. Okay, so every girl has one boyfriend. Every boy has 1 girlfriend. Everyone's happy. Okay, if this example, I think it's a bad example, but if helps you understand, then go ahead, think about in this way. But I think it's a bad example. Sorry, I should not do that. Anyway, the definition is more important, but I do hope that helps you understanding this. Let's see, how do we prove a function is bijective? So to show a function is bijective, we need to show it's injective and surjective. So first of all, let's show it's injective. So let's go back to the definition a bit. What the definition I'm using right now is this one. Okay, so for every x1, x2 in A, f of x1 equals to f of x2 implies x1 equal to x2. If I have this, then the function is injective. So that's what I did here. Suppose a, b, x, y are in your domain. So this is the domain x domain, such that they are the f of a, b equals to f of x, y. Then based on the function here, we get ba equals to yx. And based on this, we know that b equals to y and a equals to x. Okay, now based on this, we know that ab equals to xy, which is exactly what we need to prove here. Okay, therefore f is injective. For surjectivity, what I used is here. If for every y in B there is at least 1 x in A for which f of x equals to y. So this is the definition I'm using. So here is like for any AB in R times R, this R times R is, the codomain x R times R. There exists BA in, this is a domain, okay, such that f of BA equals to AB. So I have this and I'm done. Why is that? Because I showed, okay, let's move back, move it smaller. Because I showed that for every y in B, every y in my codomain, there exists at least 1 x in A. So there exists, this is our x in A, which is our domain, such that fx equal to y. So such that fx equal to y. So that's exactly what I showed here. That is why we are done. Okay? So it's surjective. Okay. I know some of you are so confused about the questions when you have this. I know some of you freak out when you see this. Okay, I'll give you a tip. And I'll tell you later, not now, I'll tell you later, okay, how to deal with those type of questions. Anyway, let's do this question first, and I'll tell you. So this question is a little bit hard. I don't think you'll get something like this on your quiz, but I'm giving you a harder question to prepare you better, okay? But don't freak out if you don't know how to do this question. So we have G that maps from R minus 1 to R minus 1, given by G of X equals to X over X plus 1. And I want to show G is bijective. Again, to show it's bijective, we need to show it's injective and surjective. For injectivity, I suppose I take two elements from your domain such that G of A equals to G of B. And based on this, I know that A over A plus 1 equals to B over B plus 1. And I do a little bit manipulation. Eventually, I should get A equals to B, which means my G is indeed injective. So for surjectivity, this is a little bit complicated, but I will summarize it a little bit later. But let's just have a look at this first. So I take an element from your codomain here. Okay, this is your codomain. I take an element from your codomain and I manipulate this equation such that I isolate our x. Okay? Oops. When you do this, you need to be careful. Okay, you need to make sure each of your step is reversible. Okay, and when you do this, you don't want this to be rough work, so make sure you have this. Make sure you have if and only if, because if you don't have this, it's rough work. Okay, so usually when you got here, you can just skip all those and just say take x equals to this, then your g of x would be your y. Okay, so usually you just need to do those, but for this question is a little bit different because your domain excluded -1. Okay, that is why you need to show your x cannot be -1. So to show that, we use contradiction. We suppose it actually equal to -1, and eventually you'll get -1 equal to 0, which is a contradiction. Therefore, x cannot be -1. So we know that x is real minus -1. And then you just take x equal to this. So we have g of x equals to g of y over 1 minus y, which is y. And so g is surjective. Because why, if you don't understand this part, because for all y in your codomain, we can find an element here, an element which is your x here. This is in your domain such that g of x equal to y, which is exactly the definition of surjectivity. Okay, right here. This. And that's why the function g is surjective, therefore it's bijective. Okay, I want to show you a trick when you do those type of question when you have more than one variable. I'll give you an example and hopefully you know how to do this. So, example. Sometimes when you have two variables, I suggest you to fix one variable, okay? So for example, we have f, That's from z times z to integer, and my f is ab equal to a minus b. Okay, so this is what I have. Well, to prove, first of all, you need to think, is this injective? Well, obviously no, it's not injective. Okay, I'm gonna write this. So this is not injective. This is obvious. Why? Because f of 1, 1 equal to f of 2, 2, actually bracket, bracket, bracket equals to 0. Okay, so it's not injective. How do you show, or how do you know if this function is surjective? I'll tell you one thing. Usually when you see two variables like this, you can fix one variable. Okay, so we have for any, so I'm claiming that it is surjective. Claiming that this is surjective, and I pick an element for any. Again, you pick an arbitrary element from your codomain for any a in Z, right? We have f of what equals to a. So we know that f of ab equals a minus b. So we can fix your b to 0. Okay, so f of a 0 equals to a minus 0, which is a. Therefore, you show that, in this case, you show that for all elements in your codomain, there exists at least one element, this, in your domain. Okay, I'm gonna move this a bit. For all this, there exists a 0, which is in your domain, such that f of x equal to your y. Okay, this is how you do it. A lot of time, if you fix one variable, so in this case we fixed b to 0, you can fix like a to be 0 as well. It doesn't really matter, just fix something and you'll see. Okay, so a lot of time when you see two variables, you can fix one variable and see what happens next. Anyway, that is the end of my video. If you need more practice, again, check this Google Drive here. This is called MAT102 image and bijection extra practice. Other than that, I have no more things to see. Good luck, everyone. I hope you do well. Don't study too hard. Have a good sleep. Anyway, bye.